the last section on mixtures, we're going to talk about the concentrations of mixtures. Obviously, we're talking about solutions more so than colloids and suspensions. So, there's three different ways we're going to look at the concentrations of solutions. The first one by far is the most important. It's the one we've been using a lot already this year. I kind of asked the questions about it, but I just sort of didn't give all the details yet. So, molarity. By definition, molarity is the moles of solute. Now remember, solute is the actual chemical that we're using in the situation. So salt, copper sulfate, whatever. It's the chemical, and then dissolved in 1 liter of solution. And again, the most common chemical that we use to dissolve a solute is water. Okay? So molarity. Symbol for molarity is capital M. Sometimes you see it underlined. Also, we can use the word molar. So this a phrase that we'll sometimes use is 3 molar HCl, 1.5 molar sodium hydroxide, and so on. See, the calculation's pretty straightforward. The amount of moles divided by the volume of solution. Now, this is really important. This is simply a conversion factor. Nothing more, nothing less. Okay? There's no difference to how we use this as we use molar mass. Remember, molar mass tells us the number of grams in 1 mole. Molarity is going to tell us the number of moles in 1 liter. Okay? Again, molar mass, number of grams in 1 mole. Molarity, number of moles in 1 liter. Can't say it enough. It is just another conversion factor. The thing that changes here is, what is the value of the molarity? It depends upon what you make it or what's set up in the lab. It is not a set number on the periodic table. Okay? So, say it one more time. It is just another conversion factor that allows us to relate moles back and forth with volume. Okay? So, a couple things here just to look at. Got 2 different sets of questions here. And I want you to look at these here. Which one has more salt? 1 liter of a 4 molar solution, 2 liters of a 2 molar solution, or 4 liters of a 1 molar solution? Which one actually has more salt? Remember, you got to understand what M means. That means the number of moles for every 1 liter that's poured out. So here what I'm saying, number 1, I've got a bottle in which the strength is 4 moles for every liter poured. Well, if I pour out 1 liter of a 4 moles per liter bottle, I have 4 moles of chemical. Number 2, I pour out 2 liters of a 2 molar solution. So what's this tell us? Every time I pour out 1 liter, I'm going to get 2 moles. If I don't pour out 1 liter, I pour out 2 liters. That's got 4 moles. The last one, 1 mole per liter. That means every time I pour out a liter, I get a mole. I pour out 4 liters of those. So actually, in all 3 of those cases, they all have the same amount of salt dissolved in them. So again, this is just conceptually what we're talking about. Now, if you come down here to these 3, we've got 1 liter of 2 molar, we got half a liter of 6 molar, and we got 2 liters of half a mole, or half a molar. So these 3. Well, the first one here, I got 1 liter of 2 molar, I got 2 moles. Half a liter of 6 molar. 6 molar means there's 6 moles for every liter. I pour out only half a liter, there's 3 moles. Then I pour 2 liters of half a molar solution. Well, 2 of half a molar means 1. So now that second solution is the more concentrated. All right? So those are the things that we want to kind of be able to understand in our head a little bit as we work through that. All right, so remember, we already talked molarity is a conversion factor. Okay? So, way to relate moles and volumes between solids and liquids. So let me just give kind of a simple example here. If I'm going to go between volume and moles, what I have here is I have 47 milliliters of a 1.2 molar solution. And this is our conversion factor. So I need to go from volume to moles. Now remember, molarity is moles per liter, and I got 47 milliliters. So start out with the number I'm given, 0.047 liters times a conversion factor, 1.2 moles per 1 liter. Liters cancel, and there's my answer. Okay? 1.2 moles for every liter, but I'm not pouring out a liter, I'm only pouring out 0.047 liters. The answer for this is 0.0564 moles. And actually, sig figs here, 0.056 would be the correct answer. Okay. So, in this example, I went from volume to moles. I need to go from moles to volume also. So let's say I have 0.57 moles, and I have a 2.3 molar solution. How much volume do I need to pour out to get 0.57 moles? Right? Well, I've got a bottle that has 2.3 moles for every liter I pour. I only need 0.57 moles. I'm going to need a lot less than 1 liter. So if I have 0.57 moles, for every 1 liter I pour, I get 2.3 moles to come out. So 0.57 times 2.3. Oops, sorry, 0.57 divided by 2.3. Get an answer of 0.25 liters. So what does that mean? I only need to pour out 250 milliliters of that chemical to get the moles I need. Okay. That's how we're going to use that conversion factor. All right, so a couple things here. Practice problems. I got 3 of them on page 420. Now, I'm not going to go through all these. I do want to just kind of mention a couple things here. If we go through in sample problem A, and I want you to look through it and kind of follow things there, we are given mass and volume, and you're trying to solve for polarity. In B, we're given volume and molarity, and we're asked to solve for moles. In part C, a little twist to the problem, you're given a mass, a volume, and a molarity. And again, the volume you're given is talking about that you have a certain bottle available, a certain amount of bottle, and you're asked to solve for how much volume is needed out of that bottle. And so kind of 3 different variations there that you can look at. Then the next page on 421, there are 2 practice problems. Okay, so here's 2 of the show me's that I want you to do for those. Okay. Next type of calculation is what's called molality. It's not used as much. It's the moles of chemical. Okay, again, that part's the same, but now it's kilograms of solvent instead of volume of solution. So molality, little m, molal, amount of solute divided by mass of solvent. Now, if we're using water, a milliliter of water is approximately a gram. A liter of water is approximately a kilogram. So if the solvent is water, molality and molarity are essentially the same thing. Okay. So we apply it the same way. This is a conversion factor. Okay. So treat it the same way you treat molar mass, treat it the same way you do molarity. Again, depending upon the situation, you need to know when to apply the right one. So page 423, you got sample problems D and E, and what you have there on 423, you're given a mass, you're given a mass of solute and solvent, and you're asked to find molality. Practice problem E, pretty much the same way, except now they're asking for, if you're given molality and you're given the solvent, you're trying to find the solute. So again, remember, molality is a conversion factor. All right, then practice problem 1, page 424. There's the show me for that one. And again, make sure you're doing these earlier on in the chapter so that you can get good practice and you know you're on the right track. All right, the last type of calculation we're going to look at is percentages. And this is one that we will use a little bit. Just depends on the chemical and the situation. But we could do a mixture that says, well, percent by mass, percent by volume, percent by moles. And it's a simple percent calculation. The amount of chemical that we're talking about divided by the total amount times 100. So we could say we've got a bottle that has 3% peroxide by volume. What that means is in that bottle, 3% of it is peroxide, and the remaining 97%, again, we assume, is water. Here we have 29% potassium, so 29% is potassium, and the remaining 71% is water. Except the measurement here is by mass, so obviously we're talking grams, kilograms, milligrams, something like that. Here, by volume, these measurements were probably milliliters or liters. So just a simple percentage. And again, the chemical compared to the total, and again, we're talking about solutions, so the only other thing in that component is water. So here's two I just want you to do. These are just two simple show me's. You've got 29 grams of salt dissolved in 136 grams of water. What's the percentage of sodium chloride in that solution? Volume, percent volume of rubbing alcohol. You have 52 milliliters of rubbing alcohol, which is mixed with 97 milliliters of water. What's the percentage of rubbing alcohol in that mixture by volume? All right, last thing. So we've got three different ways to measure concentrations of chemicals. Which one do we use? Well, again, it depends upon the situation, what we're given. The first one is going to definitely be molarity. We're going to use that all the time. The second most common one is more likely percentages. And then the third and least likely is molality, although the very next chapter, there is one thing that we will use for it right away. Now, where else can we use these? Well, we can use these in A to B problems involving reactions. So instead of saying we measure out 1.2 grams of sodium chloride and we're trying to find out something about B, we could now say, well, we measured out 10 milliliters of a 1.2 molar solution and we want to find out something about B. Well, from here, we can figure out how many moles. We go moles to mass to whatever else we need to. Obviously, to use this, to get there, we need to use the molarity, which is our conversion factor. So the second video will just briefly talk about how we can actually incorporate this within A to B and reaction calculations.